Okay, good day class. Alright, so yesterday we have complete up to 6.1.3.3 additional and subtraction on position vector. If by using triangle law, parallelogram law or polygon law, that one not involved, IJK. Alright, so normally the calculation will be involved IJK on position vector. So we have discussed this one last lesson. Alright, so today we are going to start 6.1.3.4 multiplication of a vector by a scalar. So again, this is in SPM. Alright, so should be no problem. Okay, so let's use one example to explain this. So let's say you are given two vectors, okay, A and B. Alright, vector A is to the east 2 unit, vector B is to the east also but 4 unit. Right, so magnitude of A 2 unit, magnitude of B 4 unit. Alright, therefore from the magnitude we can see that same direction. Okay, and same direction. So from here we can see that the magnitude of vector B is 2 times of magnitude of vector A, right? So 2 times 2, 4. Okay, therefore we can say that vector B is equal to 2A. This is the meaning of multiplication of a vector by a scalar. We multiply a vector by a number. So multiplication of a vector by vector A by a scalar lambda. Of course, lambda cannot be 0 so it becomes lambda A. So remember again, lambda A is another vector with magnitude lambda times of magnitude of original vector A. Alright, so this is a new vector. So just like the resultant vector A plus B. Is a new vector. So lambda A also another new vector where the magnitude of the new vector is lambda times of magnitude A. Alright, and this scalar lambda, if lambda is positive, this scalar lambda is positive, then the direction of lambda A will be same as the direction of A, like this. And if lambda is negative, then the direction of lambda A will be opposite with the direction of A. These are no problem, quite simple. Alright, so if involve the position vector xyz, alright, or ijk. So let's say vector r is xi plus yj plus zk. So if we write in vector column vector form, so it's xyz. Then lambda r will be lambda multiplied with vector r. Lambda multiplied with vector r. Then it becomes like this. Alright, lambda multiply each component of xyz. Okay, so this is lambda r. Okay, so multiplication of vectors by a scalar is distributive. Distributive means, let's say lambda multiplied with A plus B. Distributive means it's same as like lambda multiplied inside, become lambda A plus lambda B. Alright, it's distributive. Okay, then again, we can use this multiplication of a vector by scalar to find the ratio theorem. You learned this one in chapter 5. In chapter 5. Remember? Not the syllabus of chapter 5. Chapter 5 is regarding conics. But I have do some revision for you, right? So if a point P divides a line AB in the ratio lambda mu, then AP ratio PB will be lambda to mu, right? So in chapter 5, we are doing geometry way. We use the coordinates. Alright, lambda multiply the coordinate of B. So mu multiply the coordinate of A. But now we are using vector. Now we are using vector to find the position vector of the point that divides the line. Alright, so the formula is like this. So we have 3 different cases. Okay, case 1 is P divides AB internally. Remember, internally. Okay, so let's say A is here, B is here. Alright, so point P divides AB in the ratio of lambda mu. AP is lambda, PB is mu. Okay, so if A we have the coordinate, then we can find the position vector OA, right? And we also can find the position vector of B, OB. No, it's given. If the coordinate given, then we can find. Okay. Now we are going to find the vector position of point P. Not coordinate anymore. Chapter 5, we find coordinate. So in this chapter, we find the vector position of P, means OP. Alright, so the formula will be like this. So the position vector of P means OP will be lambda multiplied with vector B. So you see, lambda multiplied with vector B. It's always crossed like this. Plus mu multiplied with vector A. So mu multiplied with vector A. It's like cross. Okay, then over lambda plus mu. Very simple. This is when P divides AB internally. Okay, case 2 and 3 will be externally. Alright, externally also have two different conditions. Alright, two different situations. Okay, the first one is P divides AB externally, but lies on AB produce. When we say AB produce means it extends to the B side. The line AB extends to the B side. So like this. You see, this is line AB. Okay, this is line AB. So I extend the line AB to the B side. Extend again. Then the P is outside. The P is outside line AB. Alright. If still follow the ratio lambda mu, so AP is lambda. So AP is lambda. So PB is mu. Then you see opposite direction already. AP this direction. PB this direction. Alright, because of the opposite direction, therefore you see negative. Alright, so again same. Lambda will multiply with B. Like this, lambda always multiply with vector B. This one also. Then mu will multiply with vector A. So you see, still cross. But if AP is the positive direction, then PB will be negative direction. That's why you have a negative here. Alright. Then the denominator also become lambda minus mu. Okay, this one is extend to B side. Okay, case number 3 will be P also divides AB externally, but lies on BA produce. You see, now they write BA produce. Means we extend to B side. Alright, so let's say originally this is line AB. Alright, so now we extend the line to A side, to this side. So we extend the line. So P lies outside AB. Alright, so still the same. AP is lambda, so PB is mu. Alright, just now we say this direction to the right is positive. So mu positive now. Lambda is negative because opposite direction. See? So still the same. Lambda multiplied with vector B, mu multiplied with vector A. It's still cross like this. Lambda is always multiplied B, mu is always multiplied A, no matter external or internal. But if external, then you see where is the negative law. Alright, is the negative is at the B side. If the point P is at the B side, then the vector A will be negative. We memorize like this. If the P is at the A side, then the B will be negative. Alright, so OP, the position vector of point P, OP, it will be negative lambda B plus mu A, then negative lambda plus mu. Okay, so we just apply formula only. Later you will see this. Alright, so let's see example 6.1.3.4. Open your textbook, page checkpoint 6.1, page 257. Okay, so we are going to discuss question 1, then question 6 to question 12. Some will be your homework, some I will discuss. Okay, I'll show you the question first, unless your book is different. Okay, so we are going to discuss question 1, this one. You're given vector A, B, and C. So find the value of each of the following vectors. This one, we just do calculation based on the multiplication of a vector by a scalar, like this, 3A, 2B. Alright, so I am going to discuss C. Alright, I'm going to discuss C. So of course, AB will be your homework. Alright, then after that will be question 6 to 12. Okay, you check the question. So 6 to 12. So here is 6 to 10. Then later you can compare your textbook. Alright, then 11, 12 will be here. 11, 12 will be here. Alright, Okay, we will see one by one. Okay. Okay. All right, no problem. Okay. So question 1C, right? Just now I say. Okay, as usual. Question 1AB homework, checkpoint 6.1. Question 1AB homework. So I will discuss C. So you are given this 3A minus 2B minus C. C is also vector. Don't forget the notation for the vector. Alright, I expand first. Distributive ma. So 3A minus 4B plus 2C. Okay, then sub in your A lah. This is given. Of course, your question is given in the IJK form. So for me lah, I prefer write in column vector form. Easier to calculate. No problem if you really want to do in IJK form like 3. Okay, A is 2I plus J. No K. No K means 0 lah. Then minus 4B. B is I minus 3J plus 2K. Okay, then plus 2C. Plus 2C is minus 3I plus J minus 4K. Can, no problem. If you want to do this way, no problem. Then you combine all the I part. 6I minus 4I, 2I. 2I minus 6I, negative 4I. Can. Negative 4I, see? Then you do look for the I part, J part, and the K part. Then you will get this answer. Alright, no problem. Up to you. So for me, I prefer vector column form. Alright? So then I calculate 6 minus 4, 2. 2 minus 6, negative 4. Alright? So 3. 3 plus 12, 15. 15 plus 2, 17. Alright? This one is 0. Minus 8 plus 8. Minus 8 minus 8. So minus 16. Alright? Because the question give me in IJK form. So remember, the final answer you express in IJK form. Alright? So just as simple as this. So AB you do as homework. Okay? Alright, then we will go to question 6. Okay? So let's look at the question. Alright, so question 6 there. The point A and B have position vector given by AB. So you are given OA and OB. Alright, P is a point on the line segment AB. So internally, on the line segment AB means internally. Find the position vector of P if the ratio of AP, PB is given. So you are given 2, A and B. I think I solve A. So B will be your homework, yes. So the question is just like this. And you see, another way you can see external or internal is, you see both the ratio positive. So means internal, alright? Okay, so let's look at the solution. Alright, so you are given vector A and vector B. So I show you the diagram, so clearer. A, B, so P is here. For question A, the ratio is 1 to 2. Means you divide the whole line AB into 3 parts. 1, 2, 3. Or 3 equal parts. AP take 1 part, PB take 2 parts. This is the meaning. Alright, then the position vector of point OP follow the formula. Lambda B plus mu A, lambda plus B. This is lambda. This is mu. So this one multiplied this one. This one multiplies this one. Remember? Cross. Okay, so this is 1, this is 2. So 1 plus 2, 3. So I put the 1 over 3 outside lah. So lambda is 1. B is this one. Mu is 2. A is this one. So just sub in only. But of course, I sub in correct formula. Then calculate. So 6 plus 4, 10. 8 minus 2, 6. Negative 2 plus 8, 6. Alright, don't forget to multiply in the 3 lah. 1/3 lah, like this. Okay, so again the question gives us in IJK form. Alright, so the final answer we express in IJK form. Okay, so I show you 6A, so you complete 6B. Just follow the same step. Alright, okay, then we will go to question 7. Alright, so question 7 sounds like this. Can see? Okay, good, can see. Right? So question 7 like this. This one. The points A and B have position vector, given you OA, OB lah, with respect to the origin O. So if the point P divides the line AB externally in the ratio 1, 3, externally, find the position vector of P. Alright, externally. So find the position vector of P in the ratio 1, 3. Alright? Okay, so like this. I move it here, easier to see. Okay. So you are given vector A, vector B, or OA, OB lah. And you are given that the ratio for PA, PB is 1, 3. So from here you see, P to A, 1 part. P to B, 3 parts. Because externally ma. So externally, so we write P first lah. Okay? Not like just now. Just now, question 6a, this is internally. So internally, I can say AP, PB. Right? AP, PB. But this is externally. So I have to write P first. Also PA, PB. You see PA, 1 part only. PB, 3 parts. So the distance from P to A shorter, right? So from here we know that, let's say this is line AB. So externally, so from here we know that P is at this side. You have to determine this one correctly. Okay, so P is at the left hand side, near to A, because PA shorter. So we know that P is closer to A. So P, let's say P is here. Alright, so from P to A is 1 part. From P to B is 3 parts. So 1 part here, so means this is 2 parts. So means from P to B altogether 3 parts. So 1, 2, 3. So AB means we divide AB into 2 parts. Okay, so we extend. Alright, so PA is 1 part. Here, from here to here, 1 part. PB from here to here, 3 parts. Alright, so this is mu, this is lambda. Sorry, this is lambda, this is mu. So lambda multiply this, mu multiply this. Same formula. Okay? So it depends, as I say, okay, never mind. So we say AP is like this. AP this side, PB this side. So to the right is positive, PB to the right is positive. So to the left is negative lah. So lambda negative lah. This is lambda, this is mu. Okay lah, sorry. I suppose say AP and PB also lah. No, if PA, PB is 1, 3. If I write AP, PB, AP, PB, then I have to write negative 1, 3 already. Right? Because to the right is positive, so to the left is negative. Okay? So if I write PA, PB, then in positive. So if I write AP, PB, then I have to show the negative already lah. The direction, because now we are talking about vector. Okay? Direction is important. Okay, so remember this is lambda, this is mu. So lambda always multiply B, mu always multiply A. Lambda always multiply B, mu always multiply A. Just that you have to decide which one is negative. Okay, so remember, if close to A, then B negative. We remember like this. So it becomes negative lambda plus mu. Okay, so now we sub in. So negative 1, lambda is 1 so negative 1 plus 3, so 2 so I take up the 1 over 2 outside so negative lambda PB plus mu A. So just calculate. I get this and multiply the half, become this one. Again in IJK form because the question gave us in IJK form. Alright, therefore OP is negative I minus 8J plus 6K. Right? Not difficult, but you have to determine the formula correctly. You have to determine the formula correctly. Okay? So you will see that next is 9. Means I want you to do 8 and 10 as homework. So your homework is 6B, 8 and 10. Let me see. Yeah. Your homework is 6B, 8 and 10. Just now question 1 also lah. Question 1 AB. Yeah, homework, question 1AB, 6B, 8 and 10. So other than that, I will discuss. Okay? Okay, next question that I'm going to discuss is question 9. Okay, question 8. Why I don't discuss question 8? Because 8 and 9 quite similar. You see, question 8 lah, the position vector of ABC is given. So OA, OB, OC. You see, OB, only I and K, so it means J is 0 lah. Find the position vector of D if ABCD is a parallelogram. Okay, so it will be similarly here. So when I explain 9, you can do this one already. Okay, then the point of intersection between the two diagonals. Find an intersection point only. Okay, up to you lah. You can use a ratio formula, this one. You can use a ratio formula, this one. Remember, for parallelogram, the diagonal bisect each other. They go through the midpoint. Yeah, they go through the midpoint. Alright, midpoint means the ratio is 1 to 1 lah. Alright, just that simple. Use this formula, but the ratio is 1 to 1 because midpoint ma. Just you can do it already. Okay, this is question 8. Okay, now I'm going to do question 9. Okay, question 9 say the position vector of ABC also given ABC. Alright, then find the unit vector parallel to AB. So, or in the direction of AB. Unit vector, you know, right? We have done. Find the value of P such that ABC are collinear. So, the question 2 means if ABC collinear, what is your P? Alright, then C is another part. If P is -2, they tell you P is -2, then find the position vector of D so that ABCD is a parallelogram. Alright, so question 9 is quite long lah. So we go part by part. Okay, here. Okay, I move out a bit. Okay, question 9. So you are given vector A, B, C. Alright, so the question 1, unit vector in the direction of AB. So of course I must have vector AB first. So use the position vector formula. So vector AB is OB minus OA. OB minus OA. Remember class, please don't skip this step. Don't skip this step. Do it. Alright? Sub in your OB and OA. Don't skip this step. From this step, if you want to direct come to this step, can. You want to skip this one, can, but don't skip this step. Alright? Must show. Why I need to write like this? Always look at the question. Question give me IJK, my final answer in IJK form. Alright? So after I minus, I get this. Alright? So I write in IJK form lah. So this is vector A. Okay, I move it a bit here so that you still can see. Okay, then we continue. Next. Okay. 7, 8, 9. Yeah. Okay. So unit vector, we need the magnitude, right? So find the magnitude of AB lah. Remember? Very simple, right? 3 square plus 12 square plus 6 square. Square root. So I get 189. So 189 is 9 times 21. So square root 9 is 3 square root 21 lah. Alright, then the unit vector is, the unit vector in the direction of AB is divide vector AB, this one, okay, with the magnitude. So I sub in, then simplify lah, because we don't want the cert in denominator, remember? For this step, we multiply square root 21 over square root 21. After simplified, yes, we get this thing. Alright, so this is the unit vector in the direction of AB. So this is first part. Alright, so part B. Find the value of P if ABC collinear. So remember collinear concept? ABC collinear. If 3 points are collinear, right? We can form any 3 vector. AB, BC, or AC. Any. Just compare 2 only. Right? So since we already have AB just now, alright, so you just find AC or BC lah, up to you. Okay, so for me, I choose BC lah. Okay, by using the vector, position vector, so BC is OC minus OB, so sub in, so I get the answer. Alright, so this is BC. Alright, so you see, this is BC. So this is AB. Right, this is AB. I can rewrite AB. I see this is 3, 12, 6. So I factorize negative 3. Okay? For AB here, I factorize out negative 3. So become negative 3i plus become minus because negative factorize out plus 4 minus 2k. Okay, why I do this step? Because I want to compare with BC. The question tell you A, B, C are collinear. Okay, for part B, the question tell you A, B, C, by the way, don't fly. Okay, the question tell you A, B, C are collinear. So means that there must have relation between these two vectors that we choose. There must have. Even though later if you can try to find AC, you will see the relation. Okay? So this is BC, this is AB. If you just see like this, like not the same, right? But when I see, this is 3, this is 1, 4, 3, 2, okay? Then I know that I can factorize out. So when I factorize out, now you see, same. I minus 4j minus 2k. Alright, so the conclusion is, since given ABC collinear, therefore AB and BC definitely parallel. Remember the collinear concept? AB and BC must be parallel. Why I put bracket? And they must have relation. Alright, and the the common, I think it's common point. Okay, and the common point B. So in this case, because they tell us already collinear, so actually this one is not that important. So AB must be parallel to BC, so they must have relation between them. So from here, very clear. AB is negative 3, BC. See? Negative 3, and this is BC. So if this is BC, so means P minus 1 equals 1 when you compare. BC that we calculate is like this. Okay, we get this conclusion because of the parallel. So this one must be BC. So AB must be equals negative 3 BC because they are parallel. Alright, so we determine 2 BC, one from the calculation, one from the relation of they are parallel. So when you compare these two, you see minus 4j same, minus 2k same. So definitely this is also 1i. Therefore, we make conclusion P minus 1 is 1. So P equals 2. Okay? Alright, then part C. Part C, they want you to sub P equals negative 2, given. It's not same, these two B and C, no relation. Okay? So you are given P is negative 2. So only C got P here. Alright, then we submit negative 2. So your vector C is like this. Okay? And now they want us to find the position vector for D so that A, B, C, D is a parallelogram. That's why I say B and C no relation. B say ABC collinear. If ABC collinear, then P will be 2. Question C say if ABCD is parallelogram, then P is negative 2. Alright? There is no relation. So how to find D if it is parallelogram? So remember concept of parallelogram. If ABCD is a parallelogram, then AD and BC must be the same. Parallelogram means you have two pairs of parallel lines, parallel and same length. The length must be the same. Alright, so I use AD, BC. You can use ABDC, no problem. Up to you. Okay. You can use ABDC, no problem. For me, I use ADBC lah, because I have BC okay, I have BC, so I calculate AD only lah. Alright, so AD is OD minus OA, and BC is this one. This is BC. And just now the question say, right, P equals negative 2 so negative 2 minus 1, so negative 3 lah. Okay, negative 3, negative 4, negative 2. So I get my BC, and left hand side AD is OD minus OA. So we want to find OA, right? So minus OA shift, we want to find OD. So we shift OA to this side. So minus OA shift here plus OA. So this is OA, right? This is OA here. A. So just calculate. Just calculate and you get your OD. OD vector. Don't forget your vector position. Alright? The vector notation. Okay, so this is question 9. Alright? First question, the unit vector. So we must have the vector, find the magnitude, then only can find the unit vector. Alright? Second, they use the concept of collinear. And part C, they use the concept of parallelogram. Alright? So later question 8, remember question 8? So you just follow this one. Question 8, you just follow this. It's just that you need to calculate lah. You need to calculate both vector. For us, this question, because BC, I calculate here already. Alright? Okay. Okay, next. Question 10 is your homework. So let's see what is question 10. Okay, the position vector of ABC refer to the origin. You're given OA, OB, OC. Find the value of lambda is ABC collinear. Lambda is here, see? Collinear concept. So just now question 9 also have collinear concept, right? And B, find the position vector of point P. If A on AB, P on AB, see? Means internally. So if APPB is 2 to 1. This one ratio formula only. Okay, so question 10 not difficult. You can do it. Alright, so we will see question 11. Look at question 11. Alright, so question 11 say the position vector of point A and point B given, okay, OA, OB given, if AB meets the z-axis at P. Meet the z-axis at P, find the ratio APPB. So it's like this. So remember the three-dimensional axis are so X, Y, and Z. Alright, so A and B is hang in this three-dimension space lah. A and B hang in this three-dimension space. Alright, and then this line AB cut this Z-axis at P. Alright, so they want the ratio APPB. Okay, so this is question 11. Okay, stop. Alright, so this is question 11. So this is the solution. Okay? Alright, I'll move out a bit. Okay. Alright, so the question say point P lies on Z-axis. So if point P lies on Z-axis, so X and Y 0? Just seem like the two-dimensional plane, XY. Okay? If a line cut X-axis, then Y 0, right? If the line cut Y-axis, then X 0, right? So same concept. So if AB cuts Z-axis at P, then the coordinate for P will be 0, 0, and Z.
Sorry, I mix it.
Okay.